So finishing out the end of 5.5. So this is 5.5, the end of it. We're going to use our properties to expand it. So looking at the cutout that you pasted yesterday, the second property was the quotient property, which means that when you have a fraction is going to expand with what? Subtraction, good. So it'll be the numerator minus the denominator. So when I expand it, it's log base 6 of 3x to the 7th minus log base 6 of y squared. Yes. Yes, so it's always going to be the numerator first minus the denominator. All right, so then the next thing we're going to look at is what we have here in each of these pieces. I'm noticing that I have a 3 and an x to the 7th, and these two terms are being multiplied. So I'm going to expand multiplication with what? How do we expand multiplication? With addition. So this term is going to expand even more. So that's going to expand to the log base 6 of 3 plus the log base 6 of x to the 7th. And then everything after my subtraction sign is not changing yet. And then you're going to use the third property, which is the power property, which tells us that the exponent is going to move to the front. So this 7 moves right here, and the 2 moves right there. So my final answer is log base 6 of 3 plus, and then it's a 7 times the log base 6 of x minus 2 times the log base 6 of y. Yes.
When it's a log being multiplied, you don't have to expand it like into like a plus thing, or?
You mean like a log times a log? Mm-hmm. Yes, we would, but we won't have that though. That's a good question. So that would be your final answer there for expanding. All right, any questions about how we expanded that? It's fully expanded. It's fully expanded when you don't have, when I say terms, I'm looking at each one of my answers. So this, every term is by itself. So the 3 is by itself. The 3 is by itself, the x is by itself, and the y is by itself. Each term has its own logarithm. That's fully expanded. All right, let's look at our second one. Go ahead and copy that down if you haven't already. So the first thing you're going to do is distribute the exponent, so that 2 is going to be distributed. So that would be a log base 2. And then 4 squared is 16. And then you have x squared and y to the 7th. Yep, everything is being multiplied. There's no fractions, no division, no plus signs. So if you don't see an operation, that operation is multiplication. All right, so I see 3 terms. Does everyone see that? 16 is a term. X squared is a term. and y to the 7th is a term. So I see 3 terms and they're all being multiplied. And how do you expand multiplication? With addition. So each term is now going to get its own log. So it'll be the log base 2 of 16 plus the log base 2 of x squared plus the log base 2 of y to the 7th. And now looking at each one of these terms, do any of them have an exponent? They do. So we have to move the exponent. So I'm noticing that we have 2. So we have this 2 that can move. We have a 7 that can move. So my final answer would be, well, no, not my final answer. I'm going to show you 2 answers. So one of my answers would be log base 2 of 16 plus, and then I have the 2. 2 is being multiplied by the log base 2 of x plus the 7 is being multiplied by, oh wait, I gotta zoom out so I can get more space to the right. Okay, there we go. The 7 is being multiplied by the log base 2 of y. Okay, this is perfectly good for me here at Pike High School, but most of you all are going to somebody's school soon, and the professor would probably expect for you to do one more thing. Does anyone see something that we can find? There is an answer that we can actually find. The 2, not the 2 and the 7. Yep, we can actually figure out what this number is. That can be evaluated. We can quite easily figure out what the log base 2 of 16 is. So 2 to the what power is 16? 4. So the best answer would be 4 plus 2 log base 2 of x plus 7 log base 2 of y. That is the best answer. I will take either answer though. All right, so that concludes 5.5. So now let's get into our new lesson, which is 5.6. And we'll spend a couple days in 5.6. So if you're titling your notes, 5.6 is log and exponential equations. That's our homework assignment, and that is in the book. And it's due on Wednesday. So I'll give you a minute to copy that down so you can title your notes. All right, so we're going to solve about 6 or 7 equations today. That's probably all we'll have time to do. So let's start off with this first one, which honestly is, this is going back to the quiz. So see if you remember how to do that. Rewrite that equation with a common base so you can drop the base. So our first 2 equations don't require a log. So how can I rewrite a base? Which side am I going to rewrite? The 4 or the 2? 4. And how am I going to rewrite 4? 2 to the second. Good. Everything else stays the same. And because we have a common base, we can drop the base. So we have 2x equals x plus 4. Subtract the x from both sides. And we get x equals 4. Pretty basic equation. Our next equation can also be written as with a common base. So looking at this equation, you may not notice that. I'll give you a minute to copy it down first. Go ahead and copy down both of those equations. And we are going to start by isolating the exponential term. So what I mean by that is this 4 to the x and the e to the 2x. We're going to get those by itself. And that's always our strategy when we're solving for x. All right, so let's go ahead and subtract the 5. And when we subtract the 5, we have 4 to the power of x equals 16. Now we can rewrite that with a common base again. So in the beginning we couldn't, but now we can. Because 16, after we isolated that exponential term, we can rewrite it with a common base. And 16 can be written as 4 to the power of 2. Drop your bases, and your final answer is just x equals 2. All right, so now let's look at an equation where we cannot rewrite with a common base. You do need a calculator for this one. So if you don't have one, you might want to grab one. This one right here. So we do want to isolate that e to the power of 2x, so I have to get rid of this. How do I get rid of this? 6. Let's subtract it. I think that's a good idea. So we have e to the power of 2x equals 5. So now what we have to do is we have to introduce a log. When you cannot rewrite both sides with a common base. So there isn't a way that I can rewrite 5 with a base e. When that's not an option, we have to introduce a log. Now, we do have a log with a base e. Which log on our calculator has a base of e? Natural log. So we're going to put in a natural log on both sides. It has to be a natural log, though. And that's because these two are inverses. These are inverses. They actually cancel out. So because they cancel out, I just have 2x equals the natural log of 5. That exponent is actually coming down. It actually comes down, and this cancels out. So 2x equals the natural log of 5. And then to solve your answer, you divide both sides by 2. So my answer would be x equals the natural log of 5 divided by 2. Now, on a standardized test, there's some questions where it is no calculator. This is the exact answer. Go ahead and type this in your calculator to get the approximate answer. Now, when you type this in your calculator, though, most calculators, when you hit the natural log, it starts a parentheses. So when you put in the 5, you have to close the parentheses after the 5. So if you don't close the parentheses after the 5, you get the wrong answer. So make sure you close the parentheses after the 5. Then you divide by 2. So the answer that you should get would be 0.805. Any questions about that? About how we got that? Anyone not get that in their calculator? So if you don't close out that 5, you get 0.916. So you have to close the 5. All right, let's look at our next two. Go ahead and copy these two down. Now, these were actually in the video that you were asked to watch on Tuesday. Similar questions. So we'll go through these two, just in case you missed it. So you have to actually figure out what is that term that I highlighted in yellow. You need to evaluate that number. 4 to the what power is 1 over 64. You can. So what did you get? -3. So we actually figured out that what that is a -3. So now we can set this equal to 0. We're going to add the 3. When I add it, now that's a +3. Go ahead and factor that down. Two numbers that multiply to be 3 and add to -4. We don't need to make a box because A is 1. So my numbers that multiply to be +3 and add to, that multiply to be +3 and add to -4 are -1 and -3. And then you set them both equal to 0. So your answers would be x equals 1 and x equals 3. And that would be your two solutions. All right, go ahead and evaluate this term if you haven't already. Figure out what that is. That's an actual number. The log base 2 of 1 over 32. So 2 to the power of what is 1 over 32? -5. Good. So that's a -5. So you can set it equal to 0. Now this time, though, we have to make a box because A is 2. So the A term would go here, the C term goes there. We need two numbers that multiply to be 2 times 5, which is 10, and add to 7. So go ahead and find your two numbers that multiply to be 10 and add to 7. So multiplies to 10 and add to 7. What would be your two numbers? 5 and 2. So we have our 5x and our 2x. Now let's go ahead and finish factoring this out. So we have an x plus 1 and a 2x plus 5. Set them both equal to 0. 2x plus 5 equals 0. X plus 1 equals 0. So your solutions would be negative 5 over 2. That's a negative 5 over 2. And a negative 1. Negative 5 over 2. I think we have 3 more questions today. I'm not sure, but let's look at our next 2. Let me see. Yeah, we have 3 more questions. So let's go ahead and do these 2. I'll give you a minute to copy them down. So now we're talking about extraneous roots. We have to check for an extraneous root. So I'll give you a minute to copy these 2 down, and then we'll work through them together. All right, so for this first one, I want you to notice the difference between these 2 equations. They're both log equations, okay? But for this one on the left, notice that we have a log on both sides. When you have a log on both sides, you can just drop the log. That's it. So the one on the left is you just drop the log. We just drop it. But the one on the right, does the one on the right have a log on both sides? It doesn't. So when you only have a log on one side, you have to rewrite as exponential. That's the difference between the 2. When you take your test next week, you're going to have a mixture of different kinds of equations, and you're going to have to recognize the strategy to use. And it's going to vary depending upon what kind of log equation it is. So we're going to use 2 different strategies. Now, the reason why I put this red box here on this slide is because you do have to check for extraneous roots. Now, if you remember, a log equation, a log graph, has a domain from h to infinity, which means that for a log equation, I can't use any value of x. X is limited. And that's why we have extraneous solutions. For an exponential graphs have a domain of all real numbers. So we can have any x values. We don't have to worry about that. But logs have a restricted domain. Okay? If you pick up your calculator, go ahead and pick up your calculator. and type in log of 0. It should say domain error because you cannot take the log of 0. Also, if you type in log of -1, you're going to get a domain error. That's why we have to check for extraneous roots, okay? So let's go ahead and solve for these two, and then we'll talk about that a little bit more. So for this one on the left, we have a log on both sides, so we can simply drop it. So we have x plus 4 equals x squared minus 2, and we're going to set it equal to 0. So the first thing I'm going to do is subtract the 4. Whenever you're solving a quadratic, you want A to be positive. So I want to keep that 1x squared positive. That's why I'm not moving these two terms to the left. I'm moving these two to the right. So let's subtract the 4. So that gives me x equals x squared minus 6. And now I'm going to subtract the x, which gives me 0 equals x squared minus x minus 6. Go ahead and factor that down. Two numbers that multiply to be -6 and add to -1. So your solutions are x equals 3 and x equals -2. But let's make sure that they work. So what I mean is you need to take each one of those numbers and I want you to substitute it into both of these green boxes. So let's start off with the 3. And you really don't even need a calculator for it. So if you take a 3 and I put it right here, is 3 plus 4 positive? I don't care what it is. I just need to know, is it positive? 3 plus 4 is positive. We all agree with that? All right. What about over here? Is 3 squared minus 2 positive? 3 squared is 9. 9 minus 2 is positive. All right. So that means we can keep this as an answer. This is going to work. If one of the sides were negative, we would have to throw it out. All right. Let's look at -2. If I put the -2 in this first green box, -2 plus 4 is 2. That works. What about over here? -2 squared is 4. 4 minus 2 is 2. That also works. So we actually do have two solutions. And we can keep them both. We don't have to throw one of them out. Now for the equation on the right, we have to do a rewrite. We cannot solve this. We can't just drop it. Okay, so we have to rewrite it. And when I rewrite it, going back to what we learned Monday, it would be 4 to the power of 2 equals my answer. So 4 to the, remember, equals the exponent, and this is your answer. So it becomes 4 squared equals x squared minus 6x. 16 equals x squared minus 6x. Subtract the 16. All right, go ahead and factor that down. Don't say it out loud. Factor that down. Find your two numbers that multiplies. That's an ugly 6. Let me fix that. All right, that's a little better. Two numbers that multiply to give you -16 and add to -6. Set them equal to 0. And this time we're only checking it. We only have one place to check it. We only have to check it in here. Make sure that they're both positive when you put them in there. So x equals 8, x equals -2. Who got that as their answers? All right, so now let's go ahead and check it out. So put the 8 right here. 8 squared is 64. 64 minus 48 is positive, so we can keep that. So 8 is going to work. We can keep that as an answer. That's okay. Now if I do the negative 2, so what I'm doing, let me write over here what I'm doing. So I'm just taking that 8 squared, I'm taking the 8. So when I say check it, I'm just saying make sure it's positive. So if I take 8 squared minus 6 times 8, I get a positive number. I don't care what it is. I just need to know that it's positive. So we can keep it. And then when I check negative 2, negative 2 squared minus 6 times negative 2, is that going to be positive or negative? Oof. I don't think so. It's positive. Negative 2 squared is 4. When you multiply two negatives, that's also a positive. So we get 16. So they both work. We can keep them both. This is okay and this is okay. So we have 2 solutions again. Now, I don't know what you're going to have on the test. I haven't looked at it yet. But you do need to check them both, because sometimes we have to throw out one. Sometimes we got to throw them both out. All right, last question for today. Go ahead and copy down the one on the left. There's a couple different ways to do this equation, and you would get the same answer. So we could use our exponent law and move this 2 and make it an exponent, but the easier way to do it would just be to divide the 2 out, because we do need to get this log by itself. We have to isolate the log. When I divide it out, I have log base 7 of negative 2x equals 0. So again, I only have a log on one side. There's only a log on one side, so I need to do a rewrite. So when I rewrite it, it would be 7 to the power of 0 equals negative 2x. Anything to the power of 0 is 1. So 7 to the power of 0 is 1. So 1 equals negative 2x. Divide both sides by negative 2. And we get x equals negative 1/2. Now we need to check that though. Make sure when you put that in this box, when I put it in this parentheses, is negative 2 times negative 1/2 positive or negative? What do you get when you multiply 2 negatives? A positive. So can I keep that answer, or do I need to throw it out? And that would be your final answer. All right. We'll pick up here tomorrow.